Okay, so continuation. So at this point, we have to calculate the next bit value, which is the value for A2. So for this, we have to set the value of J1 to be equal to J2. And if you don't forget, if you remember, in the previous slide, we already calculate J2 is equal to 1. So in this case, we reset the value of J1 equal to J2, which is the same thing like saying J1 equal to 1. Now, after you reset the value of J1 equal to the new value, which is 1, after this step, the procedure is repeated. So for example, we can calculate the value of J2, which is equal to half of J1. And because J1 is equal to 1, the value of J2 is equal to 0. Now, please be careful. 1 divided by 2 is equal to 0. It is not equal to 0.5. Don't say it is not equal to 0.5 because we're just talking about the truncated value that we take for J2. So the truncated value of J2, which is half of J1, is equal to 0. Then after that, what we did is we take the so-called truncated value of J2, you multiply by 2. After you multiply J2 by 2, the answer, you call it JJ2. And then finally, we take the difference between J1 and JJ2. The difference will be 1 minus 0 times 2. And therefore, the difference is equal to 1. Just like I told you before, if the value of difference is equal to 0, then the bit we will set to be equal to 0. However, if the difference is not equal to 0, like it is equal to 1 in this case, then the value of the bit A2 we have to set equal to 1, like in this case. Then after that, we have to calculate the updated value of P based on the same formula, which is equal to the previous value of P multiplied by 2 and plus the difference. Well, the previous value of P is equal to 0. You times 2 and you add the difference. The difference in this case is equal to 1. And so now the updated value of P is equal to 1 after you calculate the value of the second bit A2. Well, we have some more to go. The next thing is, after we calculate the bit A1 and A2, now we calculate the bit A3. And for that, just like before, we reset the value of J1 to be equal to J2. And according to the previous slide, because J2 is equal to 0, that's why in the next step, you reset J1 equal to J2 and J2 equal to 0. So which means J1 is equal to 0. After that part is done, the procedure again is the same. You take half of J1. Half of J1 means 0 divided by 2. Half of J1, you call it J2. That value of J2, just like before, we call it, that is a truncated value of J2. Then after figure out the truncated value J2, you take that J2, you times 2. The answer of that, you call it JJ2. After you calculate JJ2, then you calculate the difference between J1 and JJ2. So the difference turned out to be 0 minus JJ2, which is the same thing as 0 times 2. 0 corresponds to J2, and this time 2 is here. So now the answer for difference is equal to 0. And according to the procedure, because the value of difference is equal to 0, that's why you set the current bit A3 equal to 0. And after that, we use the same formula again. We say the updated value of P, which is updated value, should be equal to the previous value of P, which is, by the way, is equal to 1, time 2. So you time 2 in here. You plus to the difference. But the difference is equal to 0. So you plus 0. So now we get the answer. The updated value for P is now equal to 2. Now, so far, we already figure out the bit A3. Now, the last step, we have to calculate the bit A4. Same procedure again. We reset the value of J1 to be equal to J2. And according to the previous slide, J2 is equal to 0, according to the previous slide. And therefore, the value of J1 right now is equal to 0. So the value of J1 is reset to become 0. And then we follow the same procedure. You take half of the value of J1, which is, there's some typing error here. The value of J1 is equal to 0. So 0 divided by 2 is 0. So the value of J2 is equal to 0. Okay? So this is called the truncated value. The truncated value. Truncated value. J2. Then you take the truncated value of J2, which is equal to 0. You multiply that by 2. You multiply that by 2. And the answer is called JJ2. And then after you figure out JJ2, you take the difference between J1 and JJ2. So it turned out the difference is equal to 0. And because the difference is equal to 0, that's why you have to set the index, the bit A4 equal to 0. And then finally, you update again the value of P, which is equal to the previous value of P. And we all know the previous value of P is equal to 2. Time 2, you time 2, and then you add with the difference. In this case, the difference is 0. As you can see from here, difference equal to 0. So the updated value of P is equal to 4. And that is the end of this lecture, because we already figure out the final value of P, which is equal to 4. And what does that mean? Just to make sure that you know what's going on, if you go back to the very beginning in here, I said to you, you see, corresponding to, suppose you want to calculate F2 of 8. Suppose you want to calculate F2 of 8, corresponding to K equal to 8. We need to figure out what is the value of P. And from the procedure that I just described to you, the value of P is already determined like equal to 4. So everything now we know, okay? For any level L vector, for any index K, we can use the first formula here and the second formula here to compute the value of the companion nodes. In order to compute those two companion nodes, we have to figure out the value of P according to the procedure I just described to you. So that basically will be the end of this lecture. And here's the acknowledgement.